Welcome to my Ultimate Git Mastery course. Over the next 5 hours, you're going to learn everything you need to know to use Git like a pro and work effectively with others. We're going to start off by talking about the fundamental concepts like what is Git, how to install and configure it, and then in each section, we're going to explore a different set of Git tools. We'll cover creating snapshots of your code, browsing your project history, branching and merging, collaborating with others using GitHub, and rewriting history. I'm Mosh Hamadani, and I'm super excited to be your instructor. Now let's jump in and get started. All right, before we get started, let me tell you something super important real quick. If you want to get the most out of this Git course and become a Git expert, you should watch every lesson in order. Don't skip any lessons, even if you think you know the basics. Trust me, there are a lot of bad information and misconceptions about Git out there. A lot of people don't know how Git really works, and that's why they constantly screw things up and jump on Stack Overflow for help. I don't want you to be one of them. So I've put tremendous effort into creating this course to make sure you really understand how Git works and how you can use it like a pro. But that would only happen if you watch every single lesson in order. This course is short and sweet. It's only 5 hours long, but teaches you a ton. You know me, I'm not going to waste your time with BS. With that, now let's move on to the next lesson. So what is Git and why is it so popular? Git is the most popular version control system in the world. A version control system records the changes made to our code over time in a special database called repository. We can look at our project history and see who has made what changes, when, and why. And if it screws something up, we can easily revert our project back to an earlier state. Without a version control system, we'll have to constantly store copies of the entire project in various folders. This is very slow and doesn't scale at all, especially if multiple people have to work on the same project. We will have to constantly toss around the latest code via email or some other mechanisms and then manually merge the changes. So in a nutshell, with a version control system, we can track our project history and work together. Now, version control systems fall into two categories: centralized and distributed. In a centralized system, all team members connect to a central server to get the latest copy of the code and to share their changes with others. Subversion and Microsoft Team Foundation Server are examples of centralized version control systems. The problem with the centralized architecture is the single point of failure. If the server goes offline, we cannot collaborate or save snapshots of our project. So we have to wait until the server comes back online. In distributed systems, we don't have these problems. Every team member has a copy of the project with its history on their machine. So we can save snapshots of our project locally on our machine. If the central server is offline, we can synchronize our work directly with others. Git and Mercurial are examples of distributed version control systems. Out of all these, Git is the most popular version control system in the world because it's free, open source, super fast, and scalable. Operations like branching and merging are slow and painful in other version control systems like Subversion or TFS, but they're very fast in Git. We'll talk about this later. So Git is almost everywhere. More than 90% of software projects in the world use Git. That's why almost every job description for a software developer mentions Git. So if you're looking for a job as a software developer, Git is one of the skills you must have on your resume. You should know it inside out, you should know how it works and how to use it to track your project history and collaborate with others effectively. And that's exactly what you're going to learn in this course. Let's talk about various ways to use Git. We can use Git on the command line, so we open a terminal or command prompt window to execute Git commands. This is the fastest and sometimes the easiest way to get the job done. That's why a lot of people use the command line. Now, if you don't like the command line, well, you're in luck, because most modern code editors and IDEs have built-in support for basic Git features. For example, in VS Code, we have this source control panel, which gives us the essential Git features. There are also extensions available for bringing additional Git features. For VS Code, the most popular extension is GitLens. It brings a ton of Git features in VS Code. There are also graphical user interfaces specifically made for using Git. Here on the Git website, you can find the complete list of these tools for different platforms. We have tools for Windows, Mac, Linux, Android, and iOS. Out of all these, the two most popular tools are GitKraken and SourceTree. GitKraken is my personal favorite GUI tool for Git. It's beautifully designed, it works across different platforms, and it integrates with other GitKraken products such as GitKraken boards for issue tracking and GitKraken timelines for project management. It's free for open source projects, but for commercial projects, you have to pay an annual fee. Just to let you know, I'm not an affiliate of GitKraken, I'm just a fan. The other option is SourceTree. It's completely free, but it's only available for Windows and Mac. So if you're a Linux user, you have to use GitKraken or another GUI tool. In this course, we'll be spending most of our time on the command line for a couple of reasons. The first reason is that pretty much all of these GUI tools have some limitations. They support the Git commands that people use most of the time. So even if you want to use a GUI tool, there are times you would have to roll up your sleeves and get back to the command line to get the job done. The other reason is that the command line is always available, but there are situations where a GUI tool may not be available to you. You might connect to a server remotely, and you may not have permission to install a GUI tool. If you don't know how to use the command line, then you're stuck. In practice, a lot of people, including myself, use both the command line and a GUI tool, and that's what I'm going to show you in this course. There are times that it really makes sense to use a GUI tool and not the command line, but there are other times that using the command line is faster and easier, so we'll use the command line. At the end of the day, you should use the right tool for the job. Don't be like this guy. You probably know him. Our popular superstar developer called John Smith. He thinks he's better than everyone else because he does everything in the command line. He never uses a GUI tool and he looks down at people who do. Well, let him think whatever he wants if that's what makes him happy. Who cares? So we'll be spending most of our time on the command line, but when it makes sense to use a GUI tool, I'll be showing you examples in VS Code and GitKraken because those are the most popular tools. Now, if you have never worked with a command line before, don't worry, I'm going to hold your hands and teach you everything step by step. It's a lot easier than you think. So next, we're going to install Git. All right, let's see if you have Git on your machine or not. And if yes, what version you have installed. To do this, you have to open a terminal or a command prompt window. If you're on Mac, press Command and space and then type terminal. If you're on Windows, click the search icon on the bottom navigation bar and type CMD. So here's my terminal or console window. Your terminal window might look different. It doesn't matter. This is where we're going to execute Git commands. So let's look at the version of Git on this machine. We type git -- version. So on this machine, I'm using Git version 2.19.2, but the latest version at the time of recording this video is 2.27.0. So I highly encourage you to download and install the latest version. Just head over to git-scm.com/downloads. Over here, you can find instructions for installing Git on different operating systems. It's really easy. You're not going to have any problems. Now, if you're on Windows, once you install Git, you're going to get this application called Git Bash, which is short for Born Again Shell. This is basically a command prompt window, like this one over here, but it emulates Unix or Linux environments. So throughout this course, I encourage you to use Git Bash instead of the built-in command prompt window. So what you see on the screen looks closer to what I'm going to show you in this course. So go ahead and install Git. In the next lesson, I'm going to show you how to customize our Git environment. The first time we use Git, we have to specify a few configuration settings. We have to specify our name, email, default editor, and how Git should handle line endings. We can specify these configuration settings at 3 different levels. At the very top, we have the system level. The settings that we have here apply to all users of the current computer. Below this level, we have the global level. The settings here apply to all repositories of the current user. And below this level, we have the local level. The settings here apply to the current repository or the repository in the current folder. So we can have different settings for different repositories or different projects. So here in the terminal window, we type git config, then we type -- global to specify the level at which we are defining these settings. Next, we should specify the setting we want to configure. So user.name. Here we type double quotes and type our name. Now, the reason we're adding double quotes is because we have a space in this value, okay? So that was the first setting. Once again, git config -- global. This time we're going to set user.email. Now, because we don't have a space in emails, here we don't need double quotes. So let's add our email. All right. Next, we need to specify our default editor. If we don't set this, On Mac, by default, Git is going to use Vim, which is a scary editor. A lot of people are freaked out by it. In this course, I'm going to use Visual Studio Code or VS Code. You can use any editor that you prefer. But if you want to follow along with me, I highly encourage you to download the latest version of Visual Studio Code from code.visualstudio.com. Now, on this machine, I've added Visual Studio Code to my path, so I can open it from any folder on my machine without specifying the full path. So if I type code, here's VS Code. If this doesn't work on your machine, you have to troubleshoot the issue yourself. Depending on your operating system, there are different instructions for adding VS Code to your path. So back to the terminal, let's set the default editor. Git config -- global. The setting we want to configure is core.editor. Once again, we need double quotes because here we're going to have a space. The value for this setting is code space -- wait. With the wait flag, we tell the terminal window to wait until we close the new VS Code instance. Okay, so let's go ahead. Now, all these configuration settings are stored in a text file. We can edit that file using our default editor, in this case, VS Code. So we can type git config -- global -e. This will open our default editor to edit all the global settings. Let me show you. So, all right, here's our configuration file. You can see the full path to this file on the top. The name of this file is git config. Now in this file, we have different sections. So we have the user section with 2 settings, name and email. We have the core section with these 2 settings and so on. Now back in the terminal window, you can see the terminal is waiting for us to close VS Code. So let's close this window. Now we are back in the terminal and we can execute the next command. Next, we're going to configure how Git should handle end of lines. This is a very important setting that a lot of people miss. So on Windows, end of lines are marked with 2 special characters, carriage return and line feed. On Mac and Linux systems, end of lines are indicated with line feed. So that means if we don't handle end of lines properly, we're going to run into some weird issues down the road. To prevent this, we have to configure a property called core.autocrlf, which is short for carriage return line feed. So let me walk you through a real scenario. Let's say we have 2 people here, John and Julie, working with the same repository. John uses a Windows machine, Julie uses a Mac. As I told you, on Windows, end of lines are marked with carriage return and line feed. So when John wants to check in his code into the repository, Git should remove the carriage return character from end of lines. Similarly, when he checks out his code from the repository, Git should update end of lines and add the carriage return character. To achieve this behavior, we should set this property to true. On the other hand, when Julie checks out the code, she doesn't want the carriage return character. So Git shouldn't touch end of lines. However, if carriage return is accidentally added to end of lines, perhaps because of the editor that Julie is using, Git should remove it when storing the code in the repository. To achieve this behavior, we should set this property to input, which means Git should only modify end of lines when storing code in the repository. So back in the terminal, we type git config -- global core.autocrlf. If you're on Windows, you should set this to true. If you're on Mac or Linux, you should set this to input. Let me show you a few different ways to get help about Git commands. Let's say you want to learn more about the config command. You can simply Google git config. On this page, you can see the full documentation of this command. You can see various options and how they work. We can also access the same page on the terminal window. We simply type git config -- help. This is exactly the same information you saw a second ago. Now here we can press space to go to the next page and Q to exit. Now, if you don't need a full-blown help, you just need a quick refresher, you can type git config -h. This gives us a short summary of this command and its options. So we're done with the introductory stuff. Starting from the next section, we're going to cover a lot of Git commands. Now, below this video, you can download a PDF of all the commands we're going to cover in this course. If you're starting out, don't worry too much about memorizing these commands. Instead, try to understand how they work. As you practice Git in the real world, all these commands are going to become second nature to you. Trust me. So download the cheat sheet below this video, and then I will see you in the next section. The first thing you need to know to use Git effectively is how to take snapshots of your project, which is what we're going to talk about in this section. We'll be talking about the fundamental concepts in Git that are often misunderstood. So make sure to watch every lesson in this section, even if you think you know the basics. A lot of people use the basic Git commands without having a proper understanding of how Git works, and that's why they constantly get stuck. So watch every lesson in this section. Now let's jump in and get started. All right, the first thing we're going to do is create a directory for our project. You can call this directory anything and put it anywhere on your machine. It doesn't matter. I'm currently in the projects directory. So let's create a directory called Moon and then go into this directory. So let's imagine this is our project directory. And here we can have tens or hundreds of files. The first time we want to add these files to a Git repository, we have to initialize a new empty repository. So we type git init. Look at this message. Initialized empty Git repository in, and here's the full path. So we have the Moon directory, and inside this directory, we have a subdirectory called .git. By default, this subdirectory is hidden because you're not supposed to touch it. So if we type ls to list all the files and directories here, we don't see anything. But if we type ls-a, which is short for all, we can see the Git subdirectory. If you're on Mac, you can open this with Finder. And if you're on Windows, you can open it with Windows Explorer or File Explorer. I'm not sure what it's called these days. So let's open .git. Take a look. So here's our Git directory or Git repository. This is where Git stores information about our project history. So we have directories like branches, hooks, info, objects, and references. Now, as someone using Git, you don't really need to understand this structure. This is purely implementation detail. It's how Git stores information. It's none of our business. That's why this directory is hidden, so you don't touch it. If you corrupt or remove this directory, you're going to lose your project history. Let me show you. So back in the terminal, look at this green marker. It says Git. That means we have a Git repository in this directory. Now, if you want to have a pretty colorful terminal window like this, on Mac, you need to install ZSH or Z-Shell, and on Windows, you need to install PoshGit. But don't worry about it now. These tools are completely optional to use Git. It's just for making things pretty. So here we have a Git repository. Now, if I remove the Git subdirectory, we're going to lose this repository. So rm-rf.git. Look, the green marker is gone. We don't have a Git repository here anymore. So don't touch this directory. Now, once again, let's initialize a Git repository. Beautiful. So now that we have a repository, next we're going to talk about the basic Git workflow. Now that we have a Git repository, let's talk about the basic Git workflow, what we do on a daily basis when using Git. So here's our project directory, and here's our Git repository, which is actually a hidden subdirectory in our project directory. Now, every day, as part of working on various tasks, we modify one or more files. When our project reaches a state we want to record, we commit those changes into our repository. Creating a commit is like taking a snapshot of our project. Now in Git, we have a special area or a special intermediate step that doesn't exist in most other version control systems. It's called the staging area or the index. It's essentially what we're proposing for the next commit or the next snapshot. So when we're done making changes, we add the modified files to the staging area or index, review our changes, and if everything is good, then we'll make a commit. The proposed snapshot will get permanently stored in our repository. So the staging area allows us to review our work before recording a snapshot. If some of the changes shouldn't be recorded as part of the next snapshot, we can unstage them and commit them as part of another snapshot. That's the basic Git workflow. Now let me walk you through a real example. This example is crucial, so pay close attention all the way to the end, even if you think you know the basics. Our project directory is currently empty, so we add a couple of files here. Now we are ready to record this state. So we use the add command to add these files to the staging area. Now these files are in the staging area. This is the state we're proposing for the next commit. We review these files, everything is good, so we use the commit command to permanently store this snapshot in the repository. As part of this, we supply a meaningful message to indicate what this snapshot represents. This is essential for having a useful history. So as we fix bugs, implement new features and refactor our code, we make commits, and each commit clearly explains the state of the project at that point in time. So now we have one commit in our repository. Now, a common misconception about Git is that once we commit the changes, the staging area becomes empty. This is not correct, and I think this is why a lot of people find Git confusing. So what we currently have in the staging area is the same snapshot that we stored in the repository. So this staging area is actually very similar to a staging environment we use when releasing software to production. It's either a reflection of what we currently have in production or the next version that's going to go in production. So let's continue with our example. Let's say as part of fixing a bug, we make some changes to file 1. Note that what we currently have in the staging area is the old version of file 1 because we haven't staged the changes yet. So once again, we use the add command to stage the changes. Now what we have in the staging area is the same content we have in our working directory. So let's make a commit to record this state. Now we have 2 commits in our repository. Also look at the commit message. It's describing the bug that we just fixed. Now let's say we realize that we no longer need file 2. It contains unused code. So we delete it from our working directory. But this file is still in the staging area. So once again, we should use the add command to stage this change. In this case, the deletion. This is the interesting part. Even though we're saying add file 2, Git knows that file 2 is actually deleted. So it will delete this file from the staging area or the next snapshot. Again, we make a commit to permanently record this state. Now we have 3 commits in our repository. Each commit contains a unique identifier that gets generated by Git. It's like a revision number. Each commit also contains information about what was changed, by who, when, as well as a complete snapshot of our project at the time it was created. So unlike many other version control systems, Git doesn't store the deltas or what was changed. It stores the full content. With this, it can quickly restore the project to an earlier snapshot without having to compute the changes. Now you might ask, but hey Mosh, wouldn't storing the full content in every snapshot waste a lot of space? No, because Git is very efficient in data storage. It compresses file contents and doesn't store duplicate content. Now, as someone using Git, you don't really need to know how Git stores data. That's implementation detail and may even change in the future. What you need to know is that each commit contains a complete snapshot of our project, and this allows us to quickly get back to a previous state. So that's the basic idea. Over the next few lessons, you're going to see this workflow in action. Let's start by adding a couple of files to our project. To do that, we're going to use the echo command. This is not a Git command, it's just a standard Unix or Linux command for writing content to a file. So here we're going to write hello to file1.txt. So here I'm working with a text file because I don't want this course to be specific to people who know a particular programming language like Python or JavaScript. What I'm going to show you in terms of the workflow applies to any programming languages, okay? So we write hello to file1.txt. Good. Now let's execute this command one more time and change file1 to file2. So now we have 2 files in our project. Now look at this question mark here. That means we have new files here that are not tracked by Git. Because the first time you initialize a Git repository in a directory, Git is not going to automatically track your files. So if you have 1,000 files in your project, you have to instruct Git to track them, okay? So here we're going to run git status to see the status of the working directory and the staging area. Take a look. So we don't have any commits yet. We have untracked files, which are file1 and file2. They're indicated by red because they're not in the staging area yet. To add these files to the staging area, we use the git add command. Here we can list a single file, like file1.txt, or multiple files separated by a space. We can also use patterns. So star.txt. That means all the files with the txt extension. We also have period, which adds the entire directory recursively. Now you have to be a little bit careful with this because sometimes there are files you don't want to add to your repository, perhaps large files like large binary files or log files. You don't want to add these files to your repository because they increase the size of your repository. I will show you how to ignore these files later in this section. So just remember, add period adds the entire directory recursively. In this demo, I'm going to go with this command because we only have 2 files in this directory, okay? Now our green indicator changed to yellow, which means we have stuff in the staging area that are ready to be committed. So if we run git status again, look, we have 2 new files and they're indicated by green, which means they're in the staging area. Now let me show you something interesting. I'm going to modify file 1. So once again, we're going to use the echo command to echo world. But here, instead of 1 greater than sign, I'm going to use 2 greater than signs, which means append. So we're going to append world to file1.txt. Now let's run git status again. Look what happened. We have 2 files in the staging area because they're indicated by green, but we also have 1 modified file in our working directory. So you might be asking, but hey Mosh, didn't we already add file 1 to staging area? Yes, we did, but when we ran the add command, Git took a snapshot of file 1 and added that snapshot to the staging area. So here's the current situation. In the staging area, we have the first version of file 1. We changed this file after we added it to the staging area. So what we currently have in our working directory is the second version of this file. It has some changes that are not staged yet. So back to the terminal, we run git add period or git add file1.txt one more time. Now look at the status of our working directory. Both these files are in the staging area and we don't have any unstaged changes. So next I'm going to show you how to commit this snapshot to permanently store it in our Git repository. Now we have a snapshot in the staging area ready to be permanently stored in our repository. So we type git commit -m for message. And here in double quotes, we type a short description that identifies what this snapshot represents. So here I'm going to say initial commit. Now there are times that a short one-liner description is not sufficient. You want to explain some details to give context. For example, if you worked on a bug and there were some constraints at the time you committed your code, you may want to explain those constraints. This is very valuable to both you and your coworkers. So in situations like this, we drop the message. We just type git commit. Now when we press enter, this opens our default editor, in this case VS Code, because at the beginning of the course, I configured my default editor to be VS Code, okay? So here we're trying to edit this file, commit _edit message, which is stored in our git subdirectory. So on the top, we can type a short description. Ideally, this should be less than 80 characters. Then we add a line break, and after that, we can type a long description. Now, these lines that start with a £sign are comments. They're going to get ignored. So we type whatever we want here. In this case, I'm going to say initial commit. And this is our first commit. Of course, this is repetitive. We don't want to have commit messages like this. But for this demo, I'm going to go with this message. So we save the changes. Then we close this window. Back in the terminal, our snapshot is committed. And here we have basic statistics about what was changed. So 2 files were changed, which are file 1 and file 2. And we have 3 insertions. 3 lines were inserted. In file 1, we inserted 2 lines, hello world. And in file 2, we inserted 1 line. Now look at this indicator. It turned green because our working directory is now clean. It doesn't have any new changes. So what we have in our working directory is exactly the same content we have in our staging area, which is exactly the same content we have in the last commit. Let's talk about the best practices for committing code. First of all, your commits shouldn't be too big or too small. We don't want to make a commit every time we update a file. That's just useless because we'll end up with commits like update file 1, update file 2, update file 3. It's just useless. On the other hand, we don't want our commits to be too big. We don't want to wait and implement a feature end to end before committing it. We don't want to code for 3 days and then make a commit because the whole point of committing is to record checkpoints as we go. So if you screw up, we can always go back and recover our code. So try to commit often. In the real world, you might commit 5 to 10 times a day or even more, depending on the kind of work you are doing. But this is just a basic guideline. Don't take it as a rule. Don't try to aim for 5 or 10 commits a day. So as you're coding, as you reach a state you want to record, then make a commit. Also, each commit should represent a logically separate change set. So don't mix things up. For example, if you're fixing a bug and then you accidentally find a typo in your app, you shouldn't commit both these changes in one commit. You should have 2 separate commits. One commit for the typo, another one for the bug fix. Now, if you accidentally stage both these changes, you can easily unstage them. I will show you how to do this later in this section. Next, you should give yourself the habit of creating meaningful commit messages because all of these messages are going to show up in history. So if your messages are cryptic, they're not going to be helpful to you or other team members. Now, if you followed my previous advice, if your commit represents a single unit of work, it would be easier to come up with a message for your commit. If you're doing too many things in one commit, you're not going to come up with a good message, okay? Now, in terms of the wording, most people prefer to use the present tense in their commit messages. So instead of fix the bug, you should say fix the bug. If you don't like this convention, that's totally fine, but whatever convention you use, make sure that you and other team members stick to it. So always take these best practices in mind when committing code. One of the common questions a lot of beginners have is, do we always have to stage our changes before committing them? Well, the answer is no. And in this video, I'm going to show you how to skip the staging area. But do this only if you know what you're doing. If you're 100% sure that your code, your changes don't need to be reviewed, because that's the whole point of having a staging area. So let's modify file1 and then commit it in one step. We're going to say echo test to file1.txt. Once again, we're appending this line to file1.txt, okay? All right. Now we have a yellow indicator because our working directory is dirty. So instead of running git add and then committing it in 2 steps, we're going to commit. Here we're going to supply the option -a, which means all. That means all modified files. And then, just like before, we supply a message, or we can combine these 2 options. So let's supply a message. Fix the bug that prevented the users from signing up. Let's go. Our code is committed. 1 file was changed, and we have 1 insertion. So this is how we can skip the staging area. But once again, do this only if you know what you're doing. 99% of the time, you should always stage your code before committing it to the repository. Let's say that we just discovered that we no longer need file2 in our project because it contains unused code. So to remove this file, we type rm file2.txt. Again, this is not a git command because it doesn't start with git. It's just a standard Unix command, okay? So let's go with this. Now we have a yellow indicator, which means our working directory is dirty. So let's run git status. We have 1 change that is not staged for commit. So we remove file2 from our working directory, but it still exists in the staging area. Let me prove it to you. So we type git ls-files. These are the files in our staging area. So file2 is still here, even though we removed it from our working directory. So as I told you before, every time we make changes, we have to stage those changes using the add command. So here we type git add file2.txt to stage this change or this deletion more accurately. Now let's run git ls-files one more time. So file2 is no longer in the staging area. Beautiful. Let's run git status. We have 1 change that is ready to be committed. And as you can see, it's indicated by green, which means it's in the staging area. So let's commit this change. And here we're going to say remove unused code. So to remove a file, we have to remove it from both our working directory as well as the staging area. Because this is a very common operation, Git gives us a command that does both of these steps in one go. Let me show you. So we type git rm. So instead of using the standard rm command in Unix, we use git rm. Here we list a file name, like file2.txt. We can also specify multiple files. We can also use patterns, like all text files. When we execute this command, Git removes this file from both the working directory as well as the staging area. Now let's talk about renaming or moving files. So currently we have a single file in our working directory, and that is file1.txt. Let's rename this to main.js. So we use the move command in Unix to rename file1.txt to main.js. So with this command, we can rename or move files and directories, okay? Now our working directory is dirty, so let's run git status. We have 2 changes, and both these changes are unstaged because they're indicated by red. We have a delete operation. We deleted file1.txt, and under untracked files, we have a new file. So as you saw at the beginning of this section, Git doesn't automatically track all your new files. Every time you have a new file in your project, you have to add it to the staging area, so Git starts tracking it. So once again, we have to use the add command to stage both these changes. Git add file1.txt. This is for staging the deletion. And now let's add the new untracked file, main.js. Now let's run git status one more time. Look, Git recognized that we renamed file1.txt to main.js. And this item is indicated by green, which means this is in the staging area. So renaming or moving files is a two-step operation. First, we have to modify our working directory, and then we have to stage two types of changes, an addition and a deletion. So similar to removing files, Git gives us a special command for renaming or moving files. That is git move. So instead of using the standard move command in Unix, we're going to use git move. Now let's rename main.js to file1.js. And then run git status one more time. So we have a rename operation for renaming file1.txt to file1.js. So when we use the move command, the changes are applied to both the working directory and the staging area. Now, let's commit the changes. For the message, I'm going to say refactor code. Now look at the statistics. One file was changed. We have 0 insertions because we haven't added any new lines to any of our files. And we also have 0 deletions because we haven't removed any lines from any files. In almost every project, we should tell Git to ignore certain files and directories. For example, we don't want to include log files or binary files that get generated as a result of compiling our code. Adding these files is just going to increase the size of our repository without providing any values. Every developer can have their own log files, right? So log files are not something we want to share and synchronize with other team members. So for this demo, let's create a directory called logs and then add a log file here. Once again, we can use the echo command to write hello to logs/dev.log. Now let's run git status. So Git is saying that we have an untracked directory called logs, but we don't want to add this to the staging area because we don't want Git to track this. So to prevent this, we have to create a special file called .gitignore. So this file has no name, it only has an extension, and it should be in the root of your project. So let's echo logs/to.gitignore. Now I'm going to open this file using VS Code. So code gitignore. So in this file, we have a single entry, logs/, which indicates a directory. We can list as many files and directories we want here. For example, we can include main.log. We can also use patterns, like all log files and so on. Once we are done, we save the changes back in the terminal. Now, if you run git status one more time, Git no longer says that we have a new directory called logs because it's ignoring it. Instead, it says we have a new file called .gitignore. So let's add this file to the staging area and then commit our code. So add gitignore. So this is how we can ignore files and directories in Git. Just remember, this only works if you haven't already included a file or a directory in your repository. In other words, if you accidentally include a file in your repository and then later add it to gitignore, Git is not going to ignore that. Let me show you. So let's create a new directory called bin. Let's imagine that this directory contains our compiled source code. So using the echo command, I'm going to write hello to bin/app.bin. Now let's run git status. So we have a new directory. Now we want to accidentally commit this to our repository. So we add all the changes and then commit our code. Add bin. Here's the problem. Every time we compile our code, Git is going to say that this file, bin/app.bin, is changed, so we have to stage it and then commit it. It doesn't make sense. Why do we have to commit this file every time we compile our application? So back to gitignore, let's add the bin directory here as well. Now back in the terminal, let's run git status. So we have modified gitignore, beautiful. Let's stage and commit this change. So git add period, and then git commit include bin/ in gitignore. Now in this case, Git is not going to ignore the changes in this directory because it's already tracking this directory. So let's modify our bin file by saying echo hello world to bin/app.bin. Git status. Look, Git is saying that this file is modified. This is not what we want. To solve this problem, we have to remove this file from the staging area, which is what we're proposing for the next commit. So earlier we talked about git ls-files. This command shows the files in our staging area. So as you can see, this bin file or the bin directory is already in the staging area. We should remove it here. How? Well, earlier we talked about the git remove command. I told you that with this command, we can remove a file or a directory from both the working directory as well as the staging area. But in this case, we don't want to remove this file from our working directory because that's how we launch our application. So we want to remove this file only from the staging area. How? Well, let's add -h for a quick help. So we type git rm, then we can add 0 or more options. Now here we have this option called --cached. With this, we can remove stuff only from the index. Index is the old term for the staging area. So when you look at Git documentation, most of the time you see index. So using this option, we can remove the bin directory from the index. So git rm --cached bin /. Now we get an error saying not removing bin recursively without -r. So one more time, let's look at the help for this command. We have another option called -r for recursive removal. So we want to remove the entire bin directory from the staging area. To do that, we type git rm --cached -r bin /. Beautiful. Now this entire directory is removed from the staging area. Let's verify it. So git ls-files. Our bin directory is no longer here. Now let's run git status. Look, we have one change that is ready to be committed. This directory is deleted from our staging area. So let's commit the change. Remove the bin directory that was accidentally committed. Okay, from this point forward, Git is no longer going to track the changes in this directory. So if we echo test to bin/app.bin, you can see our working directory is still clean. We don't have any changes. We can verify it using git status as well. So this is how we can ignore files and directories in Git. Now, if you head over to github.com/github/gitignore, you can see various gitignore templates for different programming languages. For example, let's look at the template for Java. So for Java projects, it's a great idea to exclude all the class files because these files get automatically generated when you compile your code. So there's no need to include them in your repository. So here we have various patterns like all the class files or all the log files. The lines that start with a hash sign, these are comments, so they get ignored by Git. So you have learned how to get the status of the working directory and the staging area using the status command. The output of this command is very comprehensive, but it's also very wordy. So as an alternative, we can supply the short status flag or -s. Let me walk you through a few examples. So for this demo, we're going to modify one of our existing files and then add a new file. So echo sky to file1.js. So we're appending a sky to file1.js. Now let's create a new file. So once again, echo sky to file2.js. Now let's run git status. We have modified file1 and we have a new untracked file. So as you can see, the output of this command is very comprehensive, but also very wordy. Now let's run git status -s. This is much easier to dice. So let me show you how this works. Here we have two columns. The left column represents the staging area and the right column represents the working directory. So we have modified file1, and that's why we have a red M in the right column, which is the working directory. So we have some changes here, but these changes are not in the staging area. That's why we don't have anything in the left column. Now file2 is a new file. That's why we have two question marks in both these columns. Now let's add file1 to the staging area. So git add file1 and then do another short status. Look, for file1, we have a green M in the left column or the staging area column. So all the changes that we had in the working area are now in the staging area. In the right column, we don't have anything. We don't have any extra changes. Now, earlier in this section, I told you that when we stage a file, Git takes a snapshot of that file and puts it in the staging area. So if you modify that file after, we have to restage the changes. Let me show you this one more time. So I'm going to modify file1 one more time. Let's echo ocean to file1.js and then run git status -s. Look what we have here. So in the left column, we have a green L, which means we have some changes in the staging area, but we have some additional changes in the working directory that are not added to the staging area. Okay, so let's add file1 to the staging area one more time, and then run git status -s. Now, all the changes that we had in the working directory are now in the staging area. So we're done with file1. Let's look at file2. So I'm going to add file2 to the staging area as well, and then run git status -s. For file2, we have a green A in the left column, which represents added. So file2 is added and file1 is modified. This is how the short status output works. So we have staged a couple of changes. Now, before committing what we have in the staging area, we need to review our code because we don't want to commit bad code or broken code to our repository. So as a best practice, always review what you have in the staging area before making a commit. Now, the status command only shows the files that have been affected, but how can we see the exact lines of code that we have staged? We use the diff command. So we type git diff -- staged to see what we have in the staging area that is going in the next commit. So let's take a look here. Now, quite frankly, comparing files using the terminal window is not really the best way to do this. Quite often we use visual tools, and I'm going to talk about that in the next video. But I think it's essential for you to understand the output of this command because there are times that you may not have access to a visual tool, or at least you may go to an interview and you may get asked, what is the output of this command? So you need to be able to explain it. So on the top, you can see that the diff utility was called with these arguments. So we're comparing A/file1.js with B/file1.js. So we're comparing two copies of the same file. The first copy is the old copy, which is what we have in the last commit. And the second copy, which is the newer copy, is what we currently have in the staging area. Okay. Now, below that, we have index, whatever. This is just some metadata. It doesn't really matter. After that, we have a legend. So changes in the old copy are indicated by a minus sign, and changes in the new copy are indicated by a plus sign. After that, we have this section. This is a header with some information about what parts of our file is changed. So currently our files are very short. They have only a few lines of text, but in the real world, your file might have hundreds of lines of code. If you change only a couple of lines, Git is not going to show the entire file. It's going to divide that file into chunks, and what we have here is just a single chunk. So every chunk has a header with some information that gives you context. So let's see what we have here. We have two segments. The first segment is prefixed with a minus sign. So this gives us information about the old copy, what we have in the last snapshot. The second segment is prefixed with a plus sign. So this contains information about the new copy, which is what we have in the staging area. So in the old copy, starting from line 1, 3 lines have been extracted and shown here. In the new copy, once again, starting from the first line, 5 lines have been extracted and shown here. So these are all these lines over here. Now you can see that these 2 lines are prefixed with a plus sign. So these are the lines that we have added in the new copy. So we have added these lines in the staging area. They're green, which means they're new lines. So pretty straightforward. Now after that, we have another call to the diff utility. This time we're comparing 2 copies of file 2. Now in this case, look at the legend. We don't have an old copy because this is an entirely new file. So in the last commit, we didn't have a file called file2. That is why in this header, we have 0, 0, which means starting from line 0, 0 lines have been extracted because there is no old copy of this file, okay? Now, what if you want to see the changes in our working directory that are not staged yet? To do that, we run git diff without any arguments. So this compares what we have in the working directory with what we have in the staging area. Take a look. There's no output here because we have staged all the changes in our working directory. We can also verify this using our short status command. So all the changes in our working directory are now in the staging area. So for this demo, I'm going to make a change to file 1. So let's open it with VS Code or our favorite editor. So I'm going to change the first line to hello world. Save. Now, let's run another short status. So for file 1, we have some changes in our working directory that are not in the staging area. Let's look at these changes using the diff command. So git diff without any arguments, take a look. So here we're comparing two copies of file 1. The old copy is what we currently have in the staging area, and the new copy is what we have in the working directory. Now take a look. In the old copy, which is indicated by a minus sign, we have this line, hello, which is removed because it's red. And in the new copy, which is what we have in the working directory, we have this new line, hello world. So to recap, if we run git diff without any arguments, we can see unstaged changes. And if we pass -- staged, we can see the state changes that are going to go in the next commit. In the next lesson, I'm going to show you how to use a visual tool to easily compare files. As I told you in the last lesson, quite often we use visual diff tools for comparing files. There's so many visual diff tools out there. The most popular ones are kdiff and p4merge, which are cross-platform, and winmerge that runs only on Windows. In this lesson, I'm going to show you how to use VS Code for comparing files. If you want to use a different tool or a different editor, you have to look up the instructions yourself. So here in the terminal, first we have to tell Git that we want to use VS Code as our default diff tool. So we have to set two configuration settings. So once again, we type git config -- global. So the global settings apply to all of our repositories, okay? Now the setting we're going to set is diff.tool. We're going to set that to VS Code. So with this command, we're just giving a name, in this case VS Code, to our default diff tool. Next, we need to tell Git how to launch VS Code. So once again, git config -- global. Here we set diff tool dot VS Code dot CMD. We set this to double quotes because we're going to have a space. Now on my machine, I've added code to my path so I can run it from any directories. If this doesn't work on your machine, you have to look up the instructions yourself depending on your operating system. So we're going to launch code with a few arguments. The first one is -- wait. This tells the terminal window to wait until we're done with VS Code. So until we have compared the changes and closed the VS Code instance. The second argument is -- this tells VS Code that we want to use it for diffing or comparing files. Then we have two more arguments, $local in capital and $remote in capital. These are placeholders for the old and new copies of a file, okay? So let's set that. Now let's make sure that you have got this step right. So we're going to run git config -- global -e. As I told you at the beginning of the course, with this command, we can edit our global configuration settings in our default editor, which is VS Code. So take a look. So all these settings are stored in this file .getconfig, which is stored in this directory. So we have the user section, which we set earlier in the course. Now here's the diff section that we just set. In this section, we have set the tool to VS Code. This is just a name. Then we have diff tool, VS Code. And here's the command that should be run for comparing files with VS Code. So we have code with -- wait, then -- Now those two placeholders that I added, for some reason they're lost. So let's add them real quick. $local and $remote. Make sure to get this right, otherwise things are not going to work on your machine. Now we're done. So let's close this window. Back in the terminal, instead of using the diff command, we're going to use diff tool. This will launch our visual diff tool for comparing files. Now, if we don't supply any arguments, we're going to see our unstaged changes. So this will compare what we have in the working directory with what we have in the staging area. If you want to look at our state changes, we supply -- stage, exactly the same way we use the diff command, okay? So let's look at the changes we have in our working directory. We have modified only a single file. That is why we have 1 out of 1, and that is file1.js. So Git is asking if you want to launch VS Code, which is the name that we assigned to our default diff tool. Let's go ahead. Take a look. So here's the old copy, which is what we have in the staging area, and here's a new copy, which is what we have in the working directory. As you can see, we can easily tell that this line has been replaced with this line. It's much easier to see the changes. Now the terminal window is waiting for us to close the VS Code instance. So let's close this window. Back to the terminal. Now let's look at the state changes. So git diff tool -- staged. Two files have been affected in the staging area. The first one is file1.js. let's look at the changes. All right, in this case, the old copy is what we have in the last commit, and the new copy is what we have in the staging area. So these are the changes that are going to go in the next commit. You can easily tell that we have added 2 lines here. Now let's close this tab. Back in the terminal, Git is asking if you want to look at the changes in file2.js. In this case, I'm going to ignore that, so no. Like, quite honestly, we don't use diff tools so much these days. I just covered it because I want my course to be comprehensive. These days, most editors and IDEs allow us to view the staged and unstaged changes as part of our development environment. I will show you how to do this later in this section. We have made a few commits so far, but where are these commits? Let me show you. So we use the log command to look at our history. Take a look. So here are all the commits we have created, sorted from the latest to the earliest. So here's our last commit on top. Each commit has a unique identifier. This is a 40-character hexadecimal string that Git automatically generates for us. You can think of it like a revision number, but unlike a revision number, it doesn't increase. It's just a unique identifier, okay? Now, next to that, we have head pointing to master. What is this? Well, we're going to talk about this a lot in the future, but master is the main branch or the main line of work in Git. In some other version control systems, it's called trunk. In Git, we can have multiple branches, so we can work on multiple features or multiple bug fixes in parallel and then combine our code. We'll talk about that later in the course. Now, head is a reference to the current branch. So this is how Git knows what branch we're currently working on. Again, we're going to talk about this a lot in the future. Now, for each commit, you can see the author, the name of the author, as well as their email, the date and time the commit was created, as well as the 1-line description. Like here, we have multiple commits that are spread across multiple pages. We can press space to go to the next page. And again, now to quit, we can press Q. Now, the log command has a few interesting options. One of them is 1 line. This shows us a short summary of the commits. So here we have the unique identifier that is shortened to 7 characters, and we only have the 1-line description. So we don't have the author as well as the date and time of each commit. We have another option for reversing the sort order. Let me show you. So git log 1 line, and then we add -- reverse. Now you can see the first commit be on top, and here's the last commit. Now the log command is very powerful. So in the future, we're going to talk a lot about it. In fact, we have a complete section on browsing history. I'm going to show you various ways to get reports from the history. For now, let's just stick to the basics. So viewing the list of commits is great, but what if you want to see what exactly we have changed in a given commit? That's when we use the show command. For example, let's say we want to look at the content of this commit over here. We type git show. Now here we need to specify the commit we want to inspect. There are 2 ways to reference a commit. We can reference it using its unique identifier. So we type D601B90. Now we don't have to type all the 7 characters. We can type fewer characters as long as we don't have another commit whose ID starts with these characters. So that's one way to reference a commit. Another way is to use the head pointer. So look, head is currently in front of the last commit. So to view the last commit, we can type head, or to look at previous commits, we can type a tilde and then specify how many steps we want to go back. So if we type 1, we start from head, which is here. We go 1 step back, and this references this commit over here. Let's take a look. So on the top, we can see the author and the date of this commit, as well as its message. Below that, we have a diff of what is changed. So in this commit, we have changed a single file, that is git ignore. Over here, we can see that we removed this line and added these 2 lines. So this is very useful. Now, what if we don't want to see the differences? We want to see the final version, the exact version that is stored in this commit. Well, we bring up the last command, git show head ~1, then we type a colon, and here we specify the full path to a file. For example, we can say .git ignore, or if this file is in a subdirectory, we type, for example, bin/app.bin. Okay. Now let's look at git ignore. So this is the exact version stored in this commit. Now, earlier I told you that each commit contains a complete snapshot of our working directory, not just changes. But when we run the show command, we only see the differences, what is changed. what if you want to see all the files and directories in a commit? Well, for that, we're going to use a different command.